Right, yes, I had a little problems trying to charge this old iPhone 2 up, okay. In the cottage I have with this setup, I have actually charged mobile phones up, but I think I charged mine and I charged friends up as well. So maybe this old one requires the kind of higher ampage, 1 amp or something like that instead of 600 milliamps. Um, so, okay, but I'm able to charge the phone I'm using at the moment, but we can't demonstrate that at this point in time. Okay, so what we're doing is we're moving on. Okay, because we can charge lots of USB devices with this. This is why it's very grand. And then what we're doing is we're going to actually power the circuit we were using before with the capacitor. Okay, and this has been running for quite a few minutes now because I had to. I was checking stuff out and all that. So let's basically get this on. And what I've done is I made this USB lead, which basically goes into here. It's got two terminals all soldered up and stuff. So let's basically get this on. All right. So we connect that up. Right, so it's all connected up. Now we are power is going in, and we've just got to let some power in here. There we go. Instantly on we go, and you see that slowly thing because it was filling up the capacitor. Okay, but now we have a wonderful light, thermoelectric light. Okay, which is brilliant, and we've also charged the capacitor. So this disconnects it from the thermoelectric generator, so we're purely running off the capacitor again. There we are, we've switched it off, and now it's completely running off the capacitor again, and you can see basically it's gradually dying away, because obviously there's only like 0.7 joules of energy in there, okay, which would actually run this only for 3/4 of a second. 3/4 of a second, whereas with this one we can actually run it for I don't know, about what, 35 seconds or something like that. So it's about 50 times better. Okay, that's why it's absolutely amazing. So we can demonstrate that by just pulling this out. Okay, if we can do it with one hand. Now we've done it with USB connectors. Okay, we'll have to do it. We'll have to put it down. We can do it. Yeah, here we go. Off we go. Still have a light, completely disconnected. So we've kind of demonstrated a sort of little mini thermoelectric everlasting kind of lantern thing. It's just we don't. We have a very low storage capacitor, whereas we'll be moving on to the super capacitors next. Okay, but what this does is it proves this recharging with a thermoelectric generator principle. So we'll get that on again. If we can get it on. Oh, tell you. Yeah, it's like I need two hands. There we go. You see, we're on again. We obviously the water in there will have been cooled down quite a bit by now. I don't know, is it 25 minutes or something like that? Oh yes, and also we can have this miles more brighter because we're only using a teeny bit of minuscule amount of power. And basically by reducing the resistance here, this is at 10 kiloohms at the moment, k ohms. If we say reduce that down to 1, we'll get miles more brighter because we'll be using more of the kind of energy produced. So we're not actually using hardly any of this kind of energy. So if you want a direct light, it's very powerful.